All right, so lesson 6, practice lesson. Let's start with the first one. We haven't done any missing digits yet. So something plus 7 makes 3. Well, nothing plus 7 makes 3, but something plus 7 can make 13, and we can regroup the 1 as a 10, like the 10 ones as 110. That would be 6 plus 7 makes 13. 1 plus 9 is 10. Again, this must be a 14, not a 4. So I'll write my 1 where it overflows to the next thing, where my 10 tens become 100, and 10 plus 4 makes 14. 1 plus 2 plus 0. And then the next column, I don't have any overflow yet, but something plus 8 makes 6. Something plus 8 makes 16. That's an 8. And then this one's a 5. All right, let's go ahead and move to D, because then you can see if you can do it along with me. Oh, they've added a challenge to this. Okay, so 6 plus 4 plus something makes 0. Well, 6 plus 4 is 10, so we could just put another 0 here, because this 0 down here could be the 1's place of our 10, and then we regroup. 8 plus 1 is 9, plus 2 more make 11, but we need to make a 4, which we know must really be a 14. So 11 plus what makes 14? 3. 1 plus 1 is 2, plus 7 makes 9, plus 8 makes 17. So we're going to put our 7 and then overflow. All right, 6 plus 6 is 12, plus 1 makes 13, and this 3 could be a 13 if I regroup, so we're just not going to add anything to that. It's already perfect. 9 plus 1 is 10, plus what makes this last part the 13? 10 plus 3. If you kept up with that, great job. We're going to try B now. B is subtracting. So something minus 2 makes 7. All right, well, that would be 9. 5 minus something makes 7. Well, 5 minus something can't make 7, but maybe 15. So let's regroup and say 15 minus something makes 7, and that would be 8. 7 minus 0 is 7. That's perfect, so we're not going to mess with that. Something minus 6 is 4. Well, 10 minus 6 is 4. So we could put a 0 here, and to get it to be a 10, we have to regroup. Now it's a 10. 10 minus 6 is 4. And now we have 7 minus 3. All right, if you understood that and followed along, see if you can guess ahead of me on part C. 0 minus something is 3. Well, 0 minus something is not 3, but maybe if we regroup and take 10 of our 10s to make, one of our 10s to make 10 ones, we could say 10 minus something is 3. 10 minus 7. All right, 1 minus 3 is, I bet you can already see the problem. We're not sure what's in this box, but we're going to regroup from it. So I'm just going to put a slash, and we'll come back to that. And we're going to give one of them over here. So one of our hundreds will become 10 tens. 11 minus 3 is 8. Now we can figure out what this is. Minus 0 is 5. Well, if it's a 5 minus 0 is 5, that would be perfect. So what was this number in the blue box before we took one of our hundreds and regrouped it as 10 tens? Must have been 6. And then 4 minus 5, we're going to have to regroup again. So 14 minus 5 is 9. And because we have an 8 here, we must have had an 8 after we took one of our 10,000s to regroup it, which means it must have been a 9 before. Excellent. All right, if those were a little bit of a struggle, it's okay. The practice workbook doesn't actually have any like that. Let's just get your brain thinking so that you can really understand what we're doing. Okay, the first word problem that we're going to do today, and there are problems in the book. If you look on page 55 of the student book, the colorful one, section 2 and section 3 has a bunch of estimate, then find the actual value for adding, subtracting, and then some other ones that are find the values. We're going to save those to the end and see how many I can fit in. I don't want to make this video too long. All right, so the first word problem says, Eliza wants to walk at least 10,000 steps a day. So that's important. So far, she has walked 5,687 steps a day. So that's part of her goal. How many steps does she have to walk to reach her goal? So this is like a whole part problem. This is all the steps she wants to take. And then we have the one she took today. And then we have to figure out how many more steps she needs to take. So that means we just take our whole and subtract one of our parts. And for this one, I'm just going to use the stack method because this number at the bottom is a messy number. So I'm going to call this 10 thousands and make it 9 thousands so I can give 1 to my hundreds. I'm going to keep going, take one of my hundreds, make it 10 tens, and one more time, take one of my tens and make it 10 ones. Now I'm ready to finish the problem. All right, so 10 minus 7 is 3, 9 minus 8 is 1, 9 minus 6 is 3, and 9 minus 5 is 4. So she needs to walk at least 4,313 steps to reach her goal. If she walks more than that, she definitely reaches her goal, but she can't walk less than that. All right, part B says in 3 days she wants to walk 30,000 steps in all. On Monday, she walked, let's underline Monday. This is how many steps she walked on Monday, 13,459. On Tuesday, she walked 6,490. And then on Wednesday, she walked 10,870 steps. Did she reach her goal? So if we have Monday and we have Tuesday and we have Wednesday numbers and we put them all together, we can see if she reached her goal. So that means we're adding. So we're going to add all of those. So let's start by adding just Monday plus Tuesday. So 13,459 plus 6,490. All right, so that's 9. I'm going to do the adding fast because the tricky part for these is usually figuring out what to do, not so much the actual doing it. Okay, and then we're going to add to that the Wednesday. So we're going to add Wednesday. So Wednesday was 10,870. Because I underlined them in my problem, it made it really easy to find. 9, 4 plus 7 is 11. That means I have 1 to regroup. 9 and 1 makes 10, plus 8 is 18. 9 and 1 makes 10, and then I have 3 ones. All right, so when I added Monday plus Tuesday plus Wednesday, that's what that is. Is that at least 30,000? Yes, so the answer to the question is not the number, but just the word yes. All right, let's look at the next one. 68,277 people visited a museum on Saturday. I'm going to underline that. So that's Saturday. 8,649 fewer people visited the museum on Sunday than on Saturday. So I'm going to underline fewer than. So fewer people Sunday than Saturday. So if I wanted to make a chart to show this, I would need to have one long line and one shorter line. And because fewer people visited on Sunday, this would be my Sunday, and this one would be my Saturday. And now I can fill in some numbers. They told me how many people visited on Saturday, so I can go ahead and put that number in. And then the other number they gave me was not the number of people that visited on Sunday, but the people fewer than. That tells me that's my difference. That's this number right here, 8,649. That's where that one goes. So they want me to first answer about how many people. About means we're estimating. And they want to know how many people visited on both days. So what they're wanting is this number. And the next question says exactly. So first let's decide how are we going to do this. Let's make another model for this one. We're going to put Saturday and Sunday, but instead of making the model, I'm just going to make an estimate. So the first one, I'm going to call that one 70,000. I'm going to round that to the nearest 10,000. And then Sunday, yeah, I probably should make the model. All right, so here is my Saturday, and that's 70,000. Here is my Sunday, and I'm going to give an estimate for this little part right here that's missing. I'm going to change that to 9,000. I'm rounding to the nearest 1,000 for that one. So if I have 70,000 and part of that is 9,000, the other part of that would be 70,000 minus 9,000. In other words, if I think of it just as thousands, I would say 70,000 minus 9,000. So I can just do 70 minus 9, and that'll tell me how many thousands. So 70 minus 9 is 61. and that's in thousands, so 61,000. And then to estimate, because that's not what they're asking was Sunday, what they're asking was how many visited on both days. I need to add these numbers right here together. So I'm going to add those together. So 7 and 6 would be 13 10,000s, and there's still the 1. So that's my estimate. So I can put the little curvy equal sign, about 131,000 visited on both days. Now let's do it for real. Let's pick a different color. All right, so if I want to start with figuring out Sunday, so I can add Saturday and Sunday, I need to take 68,277 and subtract the real number. And those two numbers came from here and here, and I'm subtracting them so I can find Sunday. All right, so 17 minus 9 is 8. 6 minus 4 is 2. 7. 12 minus 6 is 6. 17 minus 8 is 9, and 5. All right, so that number, remember what was that? This was Saturday minus the difference between Saturday and Sunday, which means this is my actual Sunday number. And in fact, I could write it up here now that I know it. And that might help make sure that I stay on the right track and find the right thing. So now to find the exact number who visited on both days, the people that visited, I need to add the Saturday number and the Sunday number. And you can see how close this number is, the Sunday number, to our estimate over here. It's not too far off. All right, so 7 plus 8 is 15. 1 plus 7 is 8, plus 2 makes 10. 2 plus 6 is 8, plus 1 makes 9. 8 plus 9 makes 17. 5 plus 1 makes 6, and another 6 makes 12. So here's how many people actually visited. Our estimate's not too far off. It's a little, it's, you know, a couple 10,000s off, or a couple thousands off, however you want to think of it, but it's not too bad. All right. Moving on to the last two problems in our workbook before we do some of the quick and easy ones. Okay, so for this one, it says there are 25,000 paintings in an art museum. 10,500 are oil paintings, 5,200 are watercolor paintings, and the rest are pastel paintings. Before we get to the question, let's make sure we understand what's happening. We have a bunch of paintings. We'll put a box. This will be our paintings. And we have three types. We have oil paintings, watercolor paintings, and pastel paintings. That means this number is our whole, and then this, and the unknown, those three are our parts. So we could do like a whole part problem. All right, so what they want to know, let's finish reading the question. How many more oil paintings than pastel paintings are there? Well, to do that, the easiest way would be to start by drawing a model. So let's do oil, watercolor, and pastel. All right, so the oil are 10,500 and watercolor are 5,200. So the watercolor are going to be about half as long as the pastel, because 5,000 is about half of 10,000. And we can label those. So this is, I'm going to write it just inside. All right, and then 5,200. All right, and then we don't know how many pastels there are. That's just the rest of them. I can kind of estimate and use what I know. This is about 10,000. This is about 5,000, so that makes about 15,000. And there are 25,000 altogether. If I take 25,000, which is all of them, and subtract the estimate of 15,000, which is these two, it gives me 10,000. So the pastels is going to be pretty much kind of similar to the oil. I'll make it a little shorter just in case, but it might be a little longer. We'll have to see when we finish. All right, so the question is asking how many more oil paintings than pastel. So, oh, that tells us our clue. More oil paintings than pastel. That means oil is definitely the longer one. So yay, I'm glad I drew it longer. All right, so this is our difference between the two. And what they want to know is, what is that difference? That's where they want us to figure out. So what do we do to figure it out? Oh, let me add in the last piece of information that I know. all of these together is 25,000. All right, so now that we have our model, it's probably much easier to figure out what to do with this. So if we have two of the numbers and we have the total, we can find the third. So I'm going to add the two numbers for the two paintings that we know how many there are. That number, 15,700, is just these two, which means that to find this last one, oh, let's not put the star there. To find this last one, I can subtract this number. This is oil and watercolor. I can subtract that from 25,000. So 25,000 minus 15,700. So 0, 0. Let's regroup. 10 minus 7. Let's regroup again. 14 minus 5. Excellent. So now we have our number. This number is 9,300. That's our pastel number because we subtracted the oil and the watercolor from all, or from the total. Okay, so now we can find this little section right here. Before I tell you, think in your head or say out loud, how do you think I can find that difference, this between oil and pastel, to find how many more oil than pastel? If you said subtract oil minus pastel, you are right. So 10,500, that's our oil, minus 9,300, that's our pastel. So 0, 0, 2. And I'm just going to think of this as 10 thousandths minus 9 thousandths, that's 1,000. So now we have our answer. So our answer is 1,200. All right, the last word problem. This one, I'm going to scoot this up so I have more room. This one is a before and after problem. There were 34,000 residents in Upper Town. Lower Town had 950 fewer residents than Upper Town. The boundary between the two towns was moved, and Upper Town now has 27,000 residents. How many residents does Lower Town have now? That's a lot of words, and if you got confused during that, it's okay. Let's read it slowly again and see. I told you it was a before and after, but even if I hadn't told you, when it said right here, the boundary was moved, and now, that's kind of a clue. Something changed, and there's something new. And so we're going to find the before and the after. So there were 34,000 residents in Upper Town. Lower Town had 950 fewer residents than Upper Town. The boundary between the two towns was moved. Oh, there we go. That's where it stops. So this is our before. And what comes next must be our after. The boundary between the two towns was moved, and Upper Town now has 27,000 residents. And they want to know how many residents does Lower Town have now, because it has a now right here. I know they're asking about the after the boundary change. And so the question is asking from the after. So I highlighted the question in green because that matches the after color. So this is the after, and this is the before. Okay, so let's do what we know. So upper and lower. Let's see what we know. So there were 34,000 residents in Upper Town. So let's go ahead and label that. So 34,000. That's our Upper Town. Lower Town, and I got that from right here. Lower Town had 950 fewer residents than Upper Town. So Lower Town had, let's leave out the number and read it again. Lower Town had fewer residents than Upper Town. So I need to make this shorter. Just make it a little bit shorter, because 950 seems like a very small number compared to 34,000. So here's my number that Lower Town had fewer. All right, so now let's look at the after the boundary change happened. So I probably should write the word after so that doesn't get confusing. And before. Okay, so after, Upper Town now has 27,000 residents. So let's make this line shorter. Actually, let me make it even a little bit shorter, more than that. Because 27,000 is like 3 plus 4, 7,000 less than 34,000. So I feel like it's going to be kind of maybe there-ish. All right, so now we can put that number. And it wants to know how many residents Lowertown has now. Now, where did the residents go that used to be right here? Where did they go? They went to Lowertown. And so this area got cut off and got moved. So I'm going to make this as long as it used to be. And then I'm going to take, the pen's erasing itself. And then I'm going to take this little section, this dotted section that moved, and I'm going to move it down here. And I'm going to try to make it kind of the same size. Okay, there we go. So this moved to here. All right, so it wants to know how many residents the town has now. So let's see, what do we know? If we could figure out how many they had in total here, the same number would be here. These two numbers would be the same because nobody left the town, it said. The boundary just changed. So the same people that were in upper and lower together are still in upper and lower, just some of them are a different part. So let's start by figuring out what this is, and that'll help us figure out the real answer, which is how many does Lowertown have now? That's what we really want to know. All right, so up here, if we have 34,000 in Uppertown and the other has 950 fewer, we can subtract that number because it's like a whole and a part and a part. All right, so 950, that's a 0. I'm going to regroup and take 1,000 and turn it into 10 hundreds. And I'm going to do that again, so I have 10 tens. Now I can finish subtracting. 5, 0, 3, 3. Okay, so this is 33,050. Okay, so that helped me figure out this is upper minus the difference gave me lower, and this is all in the before. Okay, so now I know how many people are in each of the towns before. I can add those two together and figure out how many there are altogether. So 34,000 plus 33,050. 05076. So there were 60,050 residents altogether, which means after the boundary change, there are still that many people. I'm just going to draw an arrow. There are still 67,050 residents in the two towns, but some of them moved. We actually don't need too much trickery here with our movement. Now that we know that, we can just take this total right here and subtract how many people are in Uppertown now and figure out how many are in Lowertown. So 67,050, that's all the people. And we're going to subtract the 27,000 that are now in Uppertown, and that will tell us how many are in Lowertown. 05004. Excellent. So this number down here is 40,050. And that's our answer. That's how many residents Lowertown has now. Okay, so those are all the word problems from the book. Let's do just a couple. If you understand those and you don't really need practice estimating or adding or subtracting, you can stop the video now. If you want a little bit more practice, I'm going to start with some of the problems from number 3 on page 55 so we can practice the ones that look a little bit, I guess, trickier. All right, so the first one says 30,000 minus 270. You could break this off into a number, like you could break this off into maybe 1,000 and 29,000 and do it mentally and just subtract this from here. We know how to make 1,000. We know that we need to have 9 hundreds, 9 tens, and 10 ones. So the number would be 7 2. Oh, just kidding. That needs to be a 3 because that will have to be the one around up 3.
Sorry,
and then we can and then we can add that to the part that we never touched. So we'd have 29,730. But honestly, I think that's kind of a messy way to do it. For me, I would just take this number, and I'm gonna have to rewrite that because I erased too much. I would just line them up. 30,000 minus 270. 0. We're going to take 1, and we're going to just keep regrouping until we get all the way to where we need to be. We don't have to regroup again because we had enough ones. There's our 3, there's our 7, there's our 9, there's our 2. And see, we got the same answer, but we just did the stack method, which I think is probably easier for this one. This one was tricky because we had to go all the way to the 10,000s place to regroup. Let's do, that was number A. Let's do C. So for C, we have 3,332 plus 199. Now for this one of our tricks might be helpful. We can add 200. That's too much, and so we're going to subtract 1 back off. So this number, we're going to add 2 hundreds. So that would be 3, 5. And as I write, I know I have to subtract 1, so I'm going to take 1 off before I write the final answer. All right, let's see if there's another kind of interesting one like that. Okay, so D has, we're still in number 3. D has 8,021 minus 499. Now with this one, we can kind of do the same thing. We can subtract 500, which is too much, so we can add back 1. So for this one, there is nothing in the hundreds place. We have to think of it as 80 hundreds. So if we subtract 80 hundreds and we're taking away 5 of those, 80 minus 5 is 75 hundreds. So I'll put 75, that's hundreds. So I'm going to put the comma to show that the 5 is in the hundreds. And then as I keep writing, I have 2, but I'm not going to write a 1 because remember we have to add 1 back, so it'll be 2. I could also have done this with the stack method, like this. So 1 is not enough, so I take 1 from here and regroup it. It gives me 2. Now I'm stuck again. I don't have enough. I'm going to mark out the 80 all at once and call it 79. And then I can give one of my hundreds as 10 tens. So 11 minus 9 is 2. 9 minus 4 is 5. And then 7 doesn't have anything to subtract. And you see, get the same answer. Whichever method works best for you is fine. Let's do, you can stop the video. I'm going to move on to number 2 and do just a couple of the number 2 problems. Maybe like 3 of them. So let's see, let's do 1 subtraction, 1 adding, and 1 that has 3 numbers. So let's start with, let's do C. C is 57,250 minus 44,987. So if I wanted to estimate, I could round this to the nearest 10,000, which would be 60,000, minus 40,000. Or I could round it to the nearest 1,000, which would be 57,000 minus 45,000. Or I could go all the way down to the nearest 100 or the nearest 10, but those are not going to be as useful. If I have a 10,000s number, a number with 5 digits, I should probably round somewhere in the thousands. Because this one's not too bad, because 5 is bigger than 4 and 7 is bigger than 5. I'm going to go ahead and round using this one. So that would be 12,000. So that's my estimate. Now I'm going to find the actual value and see how close it is. So for this one, we're just going to stack them and subtract them. All right, so let's regroup so that I have enough. And we'll keep it green. So 10 minus 7. 4 is not enough to subtract 8, so I have to regroup again. 14 minus 8 is 6. 1 is not enough to subtract 9, so regroup again. 11 minus 9 is 2. 6 minus 4. 5 minus 4. So here's the actual answer, and here's the estimate. Not bad. And then we didn't use this one at all. All right, let's do an addition one from number 2. So how about, let's do number B. All right, so B is 8,057 plus 42,906. So let's think of some different ways we could round this. We could round this to the thousands. And then this one would be 43,000. We could also round it to the hundreds. in this case becomes 8,100, and this becomes 42,900. And we really wouldn't want to go all the way down to the 10. This one right here would be kind of aggravating. I mean, I can see that the 1 and the 9 would add, make it roll over, but I'm not going to deal with that when I'm estimating. We're going to keep it. The fewer things I have to roll over, the better, because the hundreds would round, would overflow, as you like to call it, and I'd have to regroup, and then that would happen again for the thousand. So I'm going to use this one. So 8 plus 43, because I have 8 thousands and I have 43 thousands, and I can add 8 and 43 in my head. 7 plus 43 is 50, and then the one more thousand for the 8. Just so you know, I'm splitting this into 7 and 1, so I can add it to the 43 easily. So that would be 51 thousands, or 51,000. Now let's stack and add and see how close the actual answer is. All right, so 7 plus 6 is 13. 5 plus 1, 0 plus 9, 8 plus 2, and then 5. So this is the actual answer, and this is our estimate. Pretty close, right? If we rounded to the nearest thousands, this would turn into that. All right, very last one. If you're tired of the video, you can turn it off, or if you want, you can do one more. We're going to do G, because it has 3 things to add, and because I think you probably like that letter.
Can I tell my future self something?
You tell your future self something? Sure, you're going to interrupt the video. All right.
Hey, future self.
All right, now go away. This is my last
Kitty,
problem.
future self.
All right, so let's round these to the nearest 1,000. So I'm rounding to the nearest 1,000. I'm going to underline this. We can remember what I'm rounding to. Oh, the 7 is going to bump this up, so this turns into 20,000. All right, so if I average, if I round these, I'm going to get, oh, these two are not pretty numbers to add. Let's round to the nearest 10,000 instead to see if that makes it easier. So now I'm rounding to the nearest 10,000. So this would be 50,000. This would be 20,000. And then this would also be 20,000. And remember, I'm looking at the one before it to see how it affects it. And in this case, all 3 of these cause that number to round up. This is much easier. So 50 plus 20 plus 20. So I have this many thousands added together. So that would be 90,000. Now this is my estimate because I've gotten all these together. All right, so we're going to add them in pieces. So we're going to add the first 2 together. And this is pulling back from the original numbers. So first 2 added together. 9 and 2 make 11. 12, 13, 4, 5, 6. And now I have to add my last number. So I'm going to bring this back up here and start a new stack. I could just add right under, but sometimes that gets confusing and you get distracted and you forget what you're doing. So I'm going to keep track of what I'm doing. This is number 1, this is number 2, and this is our last number. I'm going to call it number 3. All right, so 0, 8, 8, 12, regroup, 6, 7, 8. All right, so this is our actual answer. So look how close it is to the estimate. It wouldn't round up to that if I rounded to the nearest 10,000, but it's going to be farther away from the real answer because I rounded to the highest place value. The lower place value you can round to, the more accurate your answer is going to be. And the higher the place value you round to, the farther away your estimate's going to be from the real answer. And that's okay. We just wanted an estimate. If we had gotten an answer that was way far away from that, we would know we probably made a mistake. Estimation's good for helping you check. Okay, before I turn off the video, I'm going to explain your assignment and then I'll write it in Google Classroom. So your workbook, page 42 is where this one starts. There are a bunch of problems on that page. I'm going to mark a certain number of problems, or maybe certain problems, so you don't have to do them all. You're probably just going to do maybe 3 or 4 off that whole page. And then page 43 and 44 have 5 different word problems. The first one is broken down into pieces, so that will probably take you a little longer, and I bet you don't want to do that one. And then the last 4 are just kind of really basic word problems like the ones we worked. Some of them are going to be just kind of whole part or comparing problems, but the very last one and possibly I think the last 2 Yeah, I think it's just the last one. Anyways, I haven't read them yet, but there are at least one of them that's a before and after problem. And so I'll write in Google Classroom the different types of problems, or I'll write it right in your book so that you know which one is before and after. I want you to try one. If you don't get it right, it's okay. We'll talk about it next week. But I want you to at least try one. Okay? And you don't have to do the challenge all on page 45. But if you want to do it, you're allowed to, but you have to finish the real assignment first. Don't jump to the challenge unless you've done the assignment that I give you for starting. Okay? All right. Good luck.